So just to review, this is our parent quadratic. So how did we transform the red one? What kind of transformations happened? Right one. Oh, good. I heard right one, down one. Evan, what did you say? Vertical. Oh, okay, okay. Oh, good. Hey, Jaden, I heard you talking too. They said vertical stretch, right? Vertical stretch. I heard you. By how much? Good.
So,
Good. If you go over one, it goes down two. It's supposed to only go over one, up one. So if it's more than one, we know it was a stretch. If it's less than one, we know it was a, oh, thank you. I almost had a heart attack. Compression. There we go. So this is a vertical stretch. How much did y'all say? Tell me again. 2. Thank you. Vertical stretch by 2. I did see some stuff on the homework I liked. Sean was one of the people that did it. I'm giving you kudos. If it's a vertical reflection, I do want to show y'all this in case you see it written this way on your test. That also means it's reflected over which axis? What did I just highlight in pink? X. Very good.
X.
Also, very good, Jaden. You could also write this as x-axis reflection. You can say vertical reflection or x-axis reflection. Either one, I'll take both. Just know if they say x-axis reflection, it just means we flipped it over the x-axis, okay? All right, before I go to number 2, let's keep going with number 1. It says write the equation. So some of y'all struggled with writing the equation on your homework last night because you didn't list out the transformations like I told you to do. If you list all of these out, you don't have to look at the graph anymore. You can write the equation from these. Okay. Well, if you write the equation first, that's fine, but sometimes y'all mess that up. Like some of you messed it up on your homework. If it is vertically reflected, does everybody agree that means our A is negative because it's opening down? Okay. Then our A we said was stretched by 2, so that means the A is negative 2. If I shifted it right 1, what do I write in the parentheses? -1, very good. And then if it went down 1, what should be on the outside? -1. I feel like y'all are okay with these for the most part. If you're not, ask me a question. Even if the question is, I don't get it, can you explain a different way? That's a question.
I don't get it, can you explain it a different way?
Yes, which part? I'm gonna pause so that. Okay, so for number 2, list the transformations. What did y'all say? What do we got for number 2? Look at the equation. What are the transformations?
Left 2, up 3.
Okay. Oh my God, I just wrote left up. Left 2, up 3. Close. There we go. Good. Very good, Jaden. Vertical compression by 1/2. Good job, y'all. So I did on the test, the transformation parts are multiple choice, and I made them tricky. There's one that says vertical compressed by 2. There's one that says vertical stretch by 2. There's one that says vertical stretch by 1/2. So you have to know if it is a fraction less than 1, it is a compression, okay? Any questions on the transformations for number 2? Y'all good? All right. So for graphing it, if you look at this as vertex form, that's one way you can graph it. If you want to just look at your transformations, that's another way you could graph it. But for graphing this, where did you guys start this quadratic?
Negative.
At the vertex, which is where? Not 2, 3.
Negative.
-2, 3. Holy cow. Do y'all struggle with graphing? That's a genuine question. That took y'all a while.
I said negative.
Huh?
I said negative.
Okay, I couldn't hear you. They were saying crazy stuff in class. like 0, 0. Well, yes, that's true. I guess I understand where you're coming from. Okay, -2, 3. Now, the only other transformation this one has is we're pressing it down by a factor of 1/2. So we're making it shorter, which will make it what? Wider. Very good. Does everybody agree with that? So remember, for your next 2 points, you want a point on the left and a point on the right. So I'm going to go left 1 and right 1. So I need points right here. Look at your A value. It's positive, so it should go up, right? But how much is it going to go up by?
1/2.
Yes, good. Just 1/2. So I'm going to go up 1/2, up 1/2. And this parabola should, oh my God, I cannot connect dots. That's sad. This parabola should look wider than our normal parent function because we are pressing it down, which is going to make it wider.
Question.
Answer, maybe.
Can you do rise over run for the fractions?
So that's a great question. Rise over run does not work all the time. It does sometimes. It doesn't work on this one. So I can show you why later if you would like. But basically, when you do a table for this one, Jaden, if you go, we'll review for math 1, but rise over run only works with linear functions. You guys remember rise over run is y over x, right? So you want to run 2 and go up 1, but with this quadratic, because it's squared, if you ran 2, you actually have to go up 2. So it should be touching really up here. I didn't draw it great because I don't make y'all do 5 points. That's where the next 2 points would be. So rise over run does not work with curved functions. It only works with linear functions. That's a great question though. So you need to go over 1, up 1/2. Okay?
Okay.
Does anybody want to see why you would go up 2 if you went over 2? Henry's like, no, don't confuse me. Okay, that's fine. If you want to know, you can come to office hours today then, and I'll show you. Because it's pretty cool. If the parent function starts off with a stretch by 4, and we want to transform that and end up with a stretch by 12, how did I get from 4 to 12?
3.
Multiplied by 3.
3.
Good. So this should say vertical stretch by 3, right? Does that make sense? Look at the beginning one, figure out how you get from that one to the next one, and that's your transformation. All right, so let's look at the inside. The beginning one, and I'm going to look at the outside too, if that's okay with y'all. This vertex would be at 1, 2, right? What would the bottom one's vertex be at?
-2, -3.
Very good. -2, -3. So y'all look, how do we get from 1 to -2? How does it move? Left.
Left 3 times.
3. Good. Left 3. And then how do you get from 2 to -3?
Down 5 times.
There y'all go. Does that make more sense? Okay, good. All right. So let's pause. So just a reminder, when's our notebook check due? Friday. So my week, y'all are week B, right? My week A kids and my virtual kids, I'll put your directions on Canvas this afternoon for your notebook check. But you're just going to take a video flipping through it basically and turn that video in on Canvas. Okay? All right, page 17. This is our last topic of notes for this unit. So we're going to be talking about domain, range, and intervals of quadratics. And I'm going to abbreviate because I always seem to run out of room. We have done that. I'm sad y'all didn't remember, but it's okay. So if I ask you for the range, and you guys just told me you remember from middle school, range is biggest value minus smallest value, smallest to biggest basically, then range is talking about the y's, which means what do you guys think domain talks about? Yeah, it's got to. That's the only thing that's left, right? So let's write down our definitions for domain and range. And I think you guys have heard of domain before too. Carter, I think you were about to tell me what it was. That's okay. The math definition is very similar to the real world one. So like if you say something is in your domain in the real world, let me give you an example. Volleyball, in my domain. Basketball, in my domain. Softball, absolutely not. Your girl played left bench. Terrible. The other two are in my domain, meaning there's something that I belong to, something I was good at. Okay? Same thing with domain and math. You're basically talking about which X values belong on the graph. Okay? So the domain, the definition I'm going to give y'all is the spread of X values that a graph contains. So basically any X value that would be on that graph, that's the domain. The max or min value comes from the Y. Yep. Where it happens, that comes from the X. Good question. All right, there's a couple of different ways y'all could see domain and range. I'm going to tell you both. So we'll just do, I don't want to do an example yet, but I do want to talk to y'all about the two different ways you could see it. So the first way they can list domain or range is an interval notation. So we do need to talk about interval notation. So interval notation uses grouping symbols. What are some examples of grouping symbols? What do you mean by square? Not exponents. Just in like, think about PEMDAS. What does the P stand for? That's a grouper. Parentheses, that's a grouping symbol. So what's another example of something similar to parentheses? Brackets, there we go. Uses grouping symbols to show the interval of possible X values. So it's going to look something like this. So we're going to have parentheses, smallest X number, comma, largest X number. And then we're going to close the parentheses. Now the parentheses could also be what? What did y'all just say? Brackets. This is the part that's usually brand new to y'all. Braces. Yeah, so braces are used in statistics for sets. They're not used with functions. We will only use parentheses and brackets. That's a good question though. If you see parentheses, that means the border numbers, and by border numbers, I mean the smallest and the largest, border numbers are not included. If you see brackets, what do you think that would mean? Look at your definition of parentheses. They are included, good. So if you see brackets, that means your smallest and largest number are included. And I know that a lot of this is not going to mean anything to y'all until we do examples, so y'all just hang tight. There's not that many notes, and we're going to jump right into examples. And I'll do at least 4. I've got more if we need more. Y'all okay with that? So that's interval notation. The second way you could see domain and range displayed, this also goes for range, is using inequality notation. Now, I'm gonna keep it real hot with y'all. I don't teach inequality notation in math 2 because you were supposed to learn it in middle school. So I will give you an example. Y'all know I will. When we do examples, I'll show you both ways. But what you're mainly going to see in math 2, and the only way you'll see it in math 3, is in interval notation. So inequality notation is just where you say X, and then you have an inequality symbol. And then whatever number. Again, I will show you examples. I don't want you to stress. Now, y'all gonna have me stressed if you don't know what a daggone inequality is. What are your inequality symbols? Greater than, good. Less than, greater than or equal to. Less than or equal to, good. So that would be inequality notation. We don't use it that often. I'll show you a trick where you can use this one to write it like this, okay? So we said domain is the spread of X values. And you guys also told me earlier that range was the Y values. A graph contains. So range is the spread of Y values that a graph contains. Now, when you guys found range in middle school, I know a lot of you said you did the biggest value minus the smallest, right? Did they ever have you list the range? I bet they did. Did y'all ever have to put the values in order from smallest to biggest? That's listing the range. So when we find range of functions, we're going to do the smallest Y value up to the biggest Y value. Okay, so you're not actually going to subtract them. You're just going to find the smallest and the biggest and list it out. So it's going to look something like this, kind of like what we wrote up there. Smallest Y number to the biggest Y number. Everybody okay so far? I know it just sounds confusing and you're like, what the heck? It's really not bad. There's a reason why I save it for last. And then the last notes, and then we're just going to jump into examples, are intervals of quadratic functions. So not interval notation, actual intervals. Does anybody in here run track? Sean, pick your head up. About to throw something at you. Huh? No, that ain't running track. You're on the track team. I couldn't throw a shot put. I'd get dizzy just spinning around once. So when you run track or cross country, because I know some of you know people that run cross country, sometimes they'll make you do like sprint intervals or distance intervals, right? Yes. Okay, fantastic. That's kind of what this is talking about. So when we look at a quadratic, I'm gonna draw y'all a picture. You don't need to draw this, just look. How many intervals do you think there are? Good, how'd you guess 2? Huh? No, you do know. You said 2 very fast. That was not just a guess. Why do you think there's 2, Evan? Yes, oh good. Okay, the vertex is in the middle. How many sides are there? 2. One of the sides is going to decrease and the other side is going to increase. There's your 2 intervals. So just looking at this picture, could you guys tell me which side is the interval of decrease, the left or the right? The left, because if you trace it with your finger, you have to go down to get to the middle, right? So this is my interval of decrease. If you look at the right side, start at the middle and go left to right, what does it do? It goes up. So that's your interval of increase. Can't you do on what, baby? No. How do you read a graph? When you read a book, how do you read? Left to right. Same with the graph. Start on the left, move to the right. Don't go the other way. That's a good question. But no, you cannot go the other way. Left to right, that's it. That's all we're doing with intervals. You're going to tell me which interval it increases on and which one it decreases on. So intervals with quadratics, we have two. We have an interval of increase, which you guys just told me is the side where it goes up, right? Yes? Okay. If I wanted to be ignored, I could stay home and talk to my dog all day because she can't answer. Goes up. I just abbreviated. And then you also have an interval of decrease, and that's the side where the graph is going to go where? Not everyone at once. Thank you, Henry. Jaden, I heard you on mute, babe. You're going to get extra credit too. It's really funny to me. It's also not funny though. It's actually sad. Sad's a better adjective. The kids who need the extra credit are usually the ones that won't ever speak up to get it. Mic drop. Henry don't need no extra credit. Sorry, Henry, to put you on blast. Neither does Jaden. You used to participate so well. Okay, what are you confused about? I'm gonna pause it. I think if we see examples, we're gonna be like, oh, this is it. And I'm gonna say yes. Okay, so let's do examples. We're gonna start off with graphs and then we will move to equations. So example 1, I want y'all to copy down this graph. Got them on the back. Vertex at 2, 1. All right, y'all. I'm gonna give you a second. I'll pause to copy this graph. If I ask you for the domain, range, and intervals, let's review. What is the domain? What am I asking you for? You can look at your notes and read me the definition. The spread of x values. Every x value that is included on this pink parabola. So let's start with domain. This pink parabola, if I'm talking about the x values, am I talking about the up and down part or the left and right part?
Left and right.
Left and right, good. So y'all look at this parabola. What do these pink arrows keep doing? They keep going down, but as they go down, they're going to get wider and wider and wider, right? So this parabola keeps going to the left and right till when?
Infinite.
Yes, okay, good. He said forever because the arrows means it goes on forever. Jaden, what did you just say?
Infinite.
Infinity. They go on forever. That parabola is going to keep going left and right forever and ever and ever and ever and ever. So if it's the infinity on the left, what kind of infinity do you think it is? Negative. If it's the infinity on the right, it would be
Positive.
Very good. That's your domain. Because those arrows keep going forever and ever and ever, left and right. That's it. It's not bad. That's the answer. That's the domain. That's all you gotta do. It goes left and right forever. So negative infinity, positive infinity. Now, why do you think I used parentheses and not a bracket? Remember, parentheses mean it's not included. Brackets mean they are included. He said it's because it's not included. What are you going to say? Because it's not good. Okay, good. I get what you're trying to say. Can I add on to it? Okay, they're saying in class because infinity is not there. Do y'all know how much infinity is worth? No one knows exactly. So if you can't see its worth, how are you going to include it? You can't. I'll answer for you. You can't. So if it goes to infinities, you can't use brackets. You got to use parentheses. You can't include it. Okay? All right. I'm going to move on from domain. Let's talk about the range. What did you guys tell me the definition of range was? The y's. It's all the y's on the what? Dang, what's this picture of a cross with a pink thing on it called? Thank you. All the y's on the graph, on the parabola. Parabola, sure. Look at the pink parabola. It goes down forever. Do y'all agree? The reason why is because it's got a max. Okay? So if it continues going down forever like y'all told me it did, what kind of infinity do you think is down? Negative infinity. And can we include infinity? No. So negative infinity. What's the highest y value this pink graph has?
1.
Ooh, good. 1. Be careful. Don't tell me 2. That's the x. The highest y value it has is 1. Now, can you guys see the point sitting on 1? The highest y value on the graph. You got it? Because this is a max. So it starts all the way at the bottom at negative infinity, comes up, hits 1, and then goes back down. So the highest y value it's going to reach is just 1. We can see it sitting on 1, can't we? So what kind of grouping symbol do you think I need? A bracket. Look at y'all. That's it. That's the range. It starts all the way at the bottom, goes up till it hits 1. Are we okay? All right. I don't trust some of y'all. Some of y'all ain't even trying to fake it till you make it. The interval of increase, I'm abbreviating. So the interval of increase is just where the graph is increasing. So this is what I'm going to ask y'all first. Which side is this parabola going up on, the left or the right? The left. Everybody look, if you traced it with your finger starting from left to right, start on the left, you have to go up first and then come back down, right? So does everybody agree it's increasing on the left side?
Yes.
Okay. So when is it increasing? Not where, it's on the left. Y'all just told me that. When? From what numbers does it increase? Negative infinity, because it's on the left, all the way till it hits when? Nope, that's a value.
-2.
-2 is where it will hit. When I'm asking you for a when or a where, that is a location. You're supposed to use what number? X. So it increases till it hits this turning point right here, right? So you guys just told me from negative infinity all the way till it hits what? -2. Now, I know somebody's going to ask me this, so I'm going to go ahead and show you. If you cut this parabola in half, do y'all agree with me at this point it stops? It's like when you ride a roller coaster and you get to the top and then they always stop you for a second before you go down for the suspense, right? At this point in the middle, it's not increasing or decreasing. It's just sitting there. So that's where it's cut in half. What's that line called again? Axis of symmetry. So it's going to increase on the left. Y'all just told me the arrows go on forever. So negative infinity all the way till it hits that midline. And that axis of symmetry is at -2, right? Is everybody okay with that?
Yes.
Okay. We're going to move on. Hang on. I'm not going to finish. Hang on. You're getting ahead of me. There's a reason I left it blank. Okay, what's your other question? It's always infinity. If there's little arrows on the end, because it keeps going. We don't know what it goes to. Wouldn't it be what then? What if it doesn't have an arrow? If it has a point, it'll just be whatever number that starts at. Yep, good question. All right, which side is it decreasing on?
On the right side.
There's only one other side we ain't done. Thank you, Jaden. The right side, when does it start going down?
-2.
-2. And it's going to keep decreasing all the way over here to the right till it hits what? Good, Loria, positive infinity. Now, does everybody see how I put a not a bracket, a parenthesis with -2? Anybody want to guess why? The point is on the axis of symmetry. Think about that roller coaster like I just told y'all. Have any of y'all been to Busch Gardens? Okay, you've ridden the Griffin, I hope. Best roller coaster there. Verbolten's pretty good too. The Griffin, you get all the way to the top, and they hang you there for 7 Mississippis. Every time I've tried it, it's 7 Mississippi on the dot. You be counting slow then, but that's okay. 7 Mississippis, you got right at front row too, on the edge, so you're hanging off. It's so fun. When you're stopped up there, are you increasing? Nope, so you can't include it. Are you decreasing? Nope, so you can't include it. You're just sitting there. You're doing nothing. So both of these are going to have parentheses. That's a great question. Extra credit. It will always be parentheses for intervals, because once you hit the axis of symmetry, you're not doing either thing. That's the wall. If it's a point, then you would have a bracket. You guys won't see a point there for me because we don't do piecewise functions. You'll see that in Math 3, and they'll teach you that in Math 3. That's a good question. All right, I'm going to show you how to check yourself. Is everybody ready? You guys probably saw this in middle school, I hope. Y'all know what that R means? Ugh.
Forgot.
All real numbers. Oh, yeah. Okay, so y'all did learn domain and range because y'all all just said, ugh. That's domain and range. Negative infinity to positive infinity just means all real numbers. Now, my test says you have to write it in interval notation because this is the Math 2 level. The range, X would just be less than or equal to 1. Because I can have any number from 1 down, right? Y'all remember doing that in middle school? Yes, Connor, are you with me? Now the increase, decrease, it's intervals, so you have to write it in interval notation. But here's a way you can check yourself on domain and range. Are there any questions before we do one more? I'm gonna do another one. Don't act like that, because half of y'all ain't participating at all, so I got no idea if y'all get it or not. So we definitely doing at least one more. We do another one. Are there any questions? Let's see another one maybe. All right, example 2. This is all we're doing tomorrow too. We're practicing this and transformations. Example 2, and same thing, we're going to find domain range in both intervals. Daggone thing every single time. Don't miss that. Put negative infinity, positive infinity for the domain. Yeah, if you miss it, I'm low-key, not even to be a bully, but I'm gonna make fun of you. Because I'm sitting here telling you right now it's negative to positive. But I always got 4 or 5 people that don't be listening. He's so funny. Negative infinity to positive infinity. Always, because it always goes all the way to the left, all the way to the right. Now, for the range of this one, we need the smallest y, that's what y'all wrote down, to the biggest y. What is the smallest y you see in pink? Negative 3. Now, okay, good. Negative 3. Can we see it sitting on negative 3? So what do I need? There we go, a bracket, negative 3. What's the biggest y it's going to go to?
Positive infinity.
How'd you get positive infinity?
Because it's going to go up on the positive scale.
It's going to go up forever. Domain is left to right, smallest x, biggest x. Range is bottom to top. I sing to my math 1 kids. You probably remember this. Started from the bottom, now we're here. Started from the bottom, now my whole math class here. Start at the bottom, go up. That's how you find the range. So the bottom of this pink graph is at negative 3, and it goes up, keeps going up, so that's got to be positive infinity. That's it. That's your range. Are we okay? Which side is it increasing on?
On the right.
Yes, this one's different. Everybody look, if you traced it with your finger from left to right, if you start on the left, it goes down and then it goes up. So it's increasing on the right side this time. This should help you because I already had you labeled a point. Where, listen to the word I'm asking you, where does it start increasing? At 1. And what does it increase to, Carter, since it's going to the right? Positive infinity. You have a question? Are you sure? Okay, are you writing this down? Okay, which side is it decreasing on? The left. If you trace it with your finger, it goes down first, right? So that means it's decreasing on this side. So if it decreases on the left, where does it start decreasing if this arrow goes to the left forever? Negative.
Infinity.
Yes, negative infinity though, because it's on the left. And where, I'm saying where does it stop increasing?
1.
1. Not the value. The value is the range. Where does it happen? That's the x. Do we feel like we could do some of these on homework? Okay, before anybody leaves, you only got, I think I gave you 7 problems for homework, but listen, you only got to do domain, range, and intervals for 4 of them. The other 3 are what we did yesterday. So my people at home, your worksheet is on Canvas. If you can print it, great. If not, that's fine too. Just do it in your notebook, okay? It's doing the same stuff we did yesterday where you have to graph it by transformations first, and then you're going to find domain, range, and intervals for me. Sound good? All right, y'all got 7-ish minutes of class time. People at home, if y'all have questions, stay on.